My name's Scott Bergeon. I work at VI-grade, and today we're going to talk about our solution for ADAS and HMI studies, which is called VI-WorldSim. So the topic today, we're going to introduce WorldSim. We'll talk a little about the user interface and use of scenario definitions. Go through a little bit of what the different sensors that are available within WorldSim are, and then we'll have a use case example of running offline, unrelated to driving simulators, so a desktop application showing integration of running WorldSim with some custom software that you can interface with one of the cameras as an example. After that, I'll talk a little bit about implementation of WorldSim on driving simulators. VI-grade, if you don't know, is produces driving simulators, and WorldSim is our solution for doing graphics and traffic and ADAS solutions within our simulators, but it's also very useful from an offline perspective. I'll talk a little bit about VR and AR applications, and then there's a promotion on the back end. So some of the key features of VI-WorldSim. First, it's a high-quality graphic engine. It's built on top of Unreal 5, so it presents the visuals for your environment when you're running well. It's an intuitive, and hopefully you'll see from the presentation, very easy integration to set up and get scenarios running. Yet at the same time, it's quite powerful because you can take control of all the agents within the environment with as much precision or lack of precision as you desire. It's got a powerful traffic engine which can run, dozens, if not hundreds of vehicles and other agents, pedestrians, animals, and then there's all sorts of other items that can be added in that will interact with the traffic, cones and that kind of stuff. And then it's got a robust sensor library that allows you to have access to the information that a sensor, whether we're talking about a camera or LiDAR, would present in real time, or we also have ground truth solutions that allow you to sort of access metadata that would, in a real system, would take some post-processing, but it's available within the simulation without doing any extra work. Then we have implementation on our simulators, obviously, that allows you to take over one of the vehicles and present the control of that vehicle from the occupant of the simulator itself. In fact, all the agents can be hijacked one way or another, whether you're running it within WorldSim or have some other solution that you want to feed the data from. And then there's a pretty robust scenario authoring capability for different configurations. Example is Euro NCAP scenarios that are pre-built in. So that's the topics. So some key features of WorldSim, and I'll start on the top right. We leverage, it is built on Unreal 5.1 at the moment, and we continuously are producing updates from our development team. Usually at least one, if not more, updates a year. We have a current solution that's out there on 5.1. We've got another one coming out in May. And we use the open drive and open scenario capability so that the interaction of the WorldSim environment with other objects can be done through this sort of middleware, and you don't have to do everything object specific. Particularly, I'm thinking in terms of VR. Simulation integration is done. We can have complete control of the simulation. All of the objects in the simulation can either be run as an AI or overridden and controlled by the user. You can control the weather in the environment. You can use triggers to start new events that were predefined. You can run in an offline mode, and then the other key thing about running on particularly simulators where you've got multiple projections going on. It runs in a distributed runtime environment where if you have multiple WorldSim instances running as part of your environment, they're synced and tied to a common clock. When it comes to scenario authoring, we have a very intuitive user interface editor that hopefully you'll get a feel for, and you can set up both all the objects in their vehicles and otherwise. You can set all the trigger definitions, and then define for each object what its behavior is. Is it going to follow rules of the road? How aggressive the object is, and then placing of sensors and being able to move forward with that. Our API supports 4 different environments: Python, C++, ROS, and of course MATLAB Simulink are all environments that you can directly programmatically interact with the WorldSim environment in real time. We have an excellent VR, AR engine built on OpenXR that allows use of different kinds of headsets that you want. We worked with a number of them. And then sensor simulations itself, there's a host of different simulators or sensors that we'll talk about those. WorldSim itself comes out of the box with a pretty extensive library of different vehicles, pedestrians, animals, and objects that can interact within the world. You can always add your own. And then we have a customization mod kit capability that not only can you bring in objects, but you can create your own worlds externally and get them into the WorldSim environment through this mod kit. So pretty robust environment. When it comes to the workflow of WorldSim, there's basically 3 different use scenarios. First is what we call WorldSim Studio, which is the environment where you would build, and you can sort of run a simulation and see the definitions that you're creating. In Studio, that's where you would add all the objects that you want, define what their behavior is going to be, and run a quick simulation just to verify that your definitions are correct. And then there's a solver mode, and there's 2 different versions of that mode. You can run in an offline environment where you just launch the solver, all the AI engine and the environment is running, and then you can interact with that environment programmatically. And then separately is an online process where you would put it on a simulator. So the idea is you authorize an environment in Studio, you can interact with it either offline or online in many different places from there. So I want to talk a little bit about the user interface and scenario definition. I mentioned that we're built on Unreal 5.1, so the graphics environment is solid. And then when you use the scenario builder, the Studio, it's a very easy environment. You can go from almost nothing to having a useful scenario in a minute or 2. You'll see that in a demo that we'll run, AVI demo we'll run in a minute. So very user friendly, easy to get up and running quickly. Then of course, as you want to take more and more control of certain objects or have things done a particular way, it still has all the full power to define those. This slide is just showing a couple of screenshots of what the graphics look like. And in the environment, we have a comprehensive proving ground, a virtual proving ground that you can use where we have ride surfaces, handling, high-speed track, a dynamic platform. You can also bring in and exist particular tracks or environments, and we have customers that have their own custom ones that are only available to them. And then we also have digital twins for different city environments. This American downtown is Chicago. There's a loop in Chicago that was produced not too long ago. Wolfsburg, Germany is another fairly large area that we have defined. We've got a number of different racetracks. We have customers that do vehicle development, and we have race team customers that use those. And then, of course, you can have your own custom defined ones, whether you create them yourselves. They can be brought in through our mod kit capability, or whether you partner with us to have the environment defined and rendered for you. Here's just a couple of screenshots pulled straight out of the simulation. There's no touch up or anything done on this. This is exactly what it will look like when you run it. One of the great parts about Unreal 5 is it does a great job of managing both the visual display, but you've got all the reflecting images on vehicles for the lighting. You can control the weather, whether it's fog, rain, how wet the surface is. All of that can be part of the scenario, modified and controlled. And the scenario is also very accurate. This is just a slide showing a comparison between some locations in this was done for Wolfsburg, and one of my colleagues went to Google Maps and got a view from the exact same location there. And you can see there's a lot of realism on the WorldSim presentation, right down to where the signs are, in many places the trees, the look of the buildings. All of that is sort of a visual artwork that is rendered in this Unreal Engine as part of the presentation. And when you drive, that what you see is what you get. So it's got a very realistic feel to it. Recent additions have included improvements in lighting. Sky Dome is kind of what paints the sky above. So there's been a lot of work in Unreal, and we're leveraging for that. And then, as I mentioned before, you have control of weather effects. About the only effect that we don't really have implemented at the moment would be buildup of snow, as an example. But everything else, when it comes to rain, fog, time of day, we have control over. So here's an example run. This is just run within the studio of a network of vehicles. When you have the environment defined, not only do you have the graphics that you see, but you also have the road network that the vehicles are going to follow. They understand where the signs are, what the speed limit is, and then the AI engine controls the traffic as it runs through the environment. There's no real limitation on how much traffic you can create, other than when it comes down to CPU and GPU power. A realistic amount might be maybe 100 vehicles, something like that. And we also have an ability so that when a vehicle leaves what is the visual scene, you can have it sort of, the AI engine can repopulate it in another location. So you can even define a sort of limited number of vehicles, but have it feel like you're interacting with a much larger number. And it makes the simulation engine more efficient. Okay, so I wanted to talk just a little bit about sensor simulation. We have two different kinds of sensors. First are sort of bottom-up raw sensors like cameras, radar, LiDAR, and ultrasonics, which are sort of first principles sensors that you can attach to any object in the environment. You can put them on your sort of a ego vehicle if you're going to be on a simulator that you're controlling, but it can be on any of the other vehicles. It can be on pedestrians. You can, for instance, attach a camera to a street light if you want to have a sensor that's related to that's looking at traffic and deciding what the light schedule is. So they're available, and it's raw on simulation of the sensor itself and the kind of data that it would present. The other type of sensor that we have is, is more of a pre-evaluation sensor, where because it's a simulation, we already have, sort of a ground truth information on all the objects. And these kind of sensors, you would have to take a raw sensor and do some processing to generate the kind of data that they represent, but they just come as native, so you don't have to kind of do all that overhead yourself. So if you want to know what the ground truth is on any particular object, you can collect that. There's telemetry. We have collision detection objects. You can look at a depth perception, and that information is all sort of just presented as sort of metadata from a sensor without needing to define the details underneath. Of course, you can always go back to a raw sensor and define those yourself if you want to. So I mentioned that there's a couple of different use modes that you can use for WorldSim. If you're running in an offline simulation, meaning not on a simulator, you're just running on your desktop. You want WorldSim to run and provide the traffic for you. You can interact with that environment through ROS, through direct Python calls, through C++, and of course you can always interact through MATLAB. We have a pretty robust set of examples set up. I wouldn't say the documentation is 100% like every last detail, but we have examples of what those interactions with each one of the different types of sensors you would have is, and it's very helpful in getting you up and running in interaction pretty quick. And then not only do you have that programmatic control there, but through Simulink, you can set up a simulation. There's a library of WorldSim objects, so if you want to embed a camera into a scenario and run and let Simulink be the engine that's doing the calculation for you, you can. We have our own separate product called Car Real Time, which is for simulating the vehicle itself with a robotic controller, as a sort of a surrogate for what you would do on the simulator as the human. And you can embed Car Real Time and WorldSim into a Simulink environment and be able to get a simulation run that way as well too. So I want to walk through, I think it'll be a little clearer once you look at a use case example of running WorldSim. So this example is going to define, starting totally from scratch, we'll just walk through defining a scenario, setting the objects in that environment, adding sensors to the ego vehicle or the vehicle that is the one that you want to control. We'll save the scenario and then run WorldSim in an offline mode and show some of the programmatic interaction where we're extracting data out of some of the sensors and then doing some post-processing and feeding it back into the environment. So with that, I've got it. I think it's a 6 or 7 minute video that I'll play for you.
VI-WorldSim Studio allows the author to graphically place vehicles, pedestrians, and objects within a simulated virtual world. We start authoring our scenario by selecting our environment. VI-WorldSim comes with a comprehensive library of pre-configured base maps such as proving grounds, highway definitions, urban environments, and residential districts. For the purposes of this demonstration, we are going to select a simple 4-lane highway. The user is immediately dropped into the virtual world and is ready to start authoring their scenario. VI-WorldSim offers full control of the visual environmental conditions within your simulation. Using these UI sliders, we can set the time of day. We have full control of the wetness or water accumulation on the road. We can even make it rain, all from within the Studio user interface. We can start adding context to our scenario by placing vehicles into the scene. VI-WorldSim comes with a large library of predefined vehicles that can be selected by type, make, and model. Or you can leave it up to the system to randomly select when you're trying to place a large number of vehicles. Here, we are going to place some random vehicles into our scenario. We can define which vehicle is our ego vehicle by renaming that asset with the name ego. Within the control panel, we can set the vehicle's initial conditions such as yaw and initial velocity. We also can define how the vehicle behaves within the simulation. Here we can define if it's under AI control, deactivated, or user-controlled. In addition, we can define behaviors such as avoiding collisions, does the vehicle obey traffic rules, and set the level of driver's aggression. Finally, we have control over the vehicle visual appearance and can define its color. Let's preview the scenario running. This is achieved by simply pressing the preview play icon. Now we have defined the basic vehicle behavior. We can add more complex interactions through the use of scripted components. Here we're adding a simple trigger event to this scenario. Defining the trigger's location is achieved by dragging and clicking within the scene. Through the UI control panel, we have full control of the trigger's XYZ location, width, length, and yaw rotation. Now, we want to define the behavior that happens when this trigger is activated. We select our ego vehicle as the activator. Next, we select the targets that will take action when the trigger is activated. In this case, all vehicles are selected. And finally, we define the actions that will take place. Here we define the action as the target vehicles will all change lanes to the right. We can preview the simulation and observe the trigger being activated. Notice how the multi-agent traffic controller manages the vehicles and makes them all change lanes to the right while avoiding collisions and obeying the defined traffic rules. Back in editing mode, we are going to add more complexity to this scenario by adding some additional vehicles. This will create a more denser traffic scene. Next, we can add in some construction barrels to block some of the lanes. VI-WorldSim comes with a library of predefined obstacles that can be placed within the scene. Again, we can preview our progress by pressing the preview play icon. Obstacles are AI-aware, meaning the multi-agent traffic controller will direct the vehicles within the simulation to avoid the placed obstacles while still obeying the defined traffic rules. Now, we want to add some sensors to our ego vehicle. The way we do that is we create a sensor pack. Within the sensor configuration window, we can add and define various sensor types. VI-WorldSim offers a variety of sensor types including RGB camera, depth camera, instant segmentation, laser scanner, LiDAR, radar, and ultrasonics. For the purposes of this demonstration, we will add one of each sensor type into the sensor pack using the default sensor parameter values as shown. And finally, we can save the sensor pack off into a sensor definition file to allow for future reuse of the defined sensors. Now we can apply the pre-saved sensor pack to our ego vehicle. Note that after application, the sensors defined within the sensor pack are shown as attached and are listed within the user interface. We can save our final scenario. The scenario is saved into a readable JSON format and can be reused and shared between other editors, as well as across all of the VI-grade vehicle simulators. VI-WorldSim can be run in several modes. As an interactive scenario editor, as shown previously, as a visual node for driving simulation, and as an offline analysis tool. In this demonstration, we are going to run in offline mode and preview the output of the simulation sensors via the Python SDK. The sensor data is streamed out of the running simulation via frame buffers on a ZMQ message bus. VI-WorldSim comes with working examples showing how to decode these streams and process the sensor outputs. We can send a command to the offline session to start the simulation. Then we can execute one of our sensor processing Python scripts to view the RGB camera sensor output. By executing the different Python scripts, we can visualize in real time each sensor's data. Starting with the RGB camera, we get a frame-by-frame rendering of the camera view. With the depth camera, each pixel is color-coded in grayscale that represents each object's depth within the scene. When using the image segmentation camera, each object within the scene is assigned a unique color, and each pixel is rendered to identify the visible objects within each frame. The radar data can be plotted to show each detected object's distance and angle within the sensor's field of view. And finally, the LiDAR point cloud data can be visualized using third-party rendering components. Here in this example, we are using the Open 3D library. We can combine processes to the sensor data outputs to support development of a perception algorithm. Here we take the output of the RGB camera and analyze each frame in a multi-stage process that results in the real-time detection of road lane markings.
Okay, hopefully that was instructive. You know, this example was pretty easy to put forward, and we've got people that could help you do something similar. It's just a bit of simple post-processing of taking that image and I think ran through 7 different transformations, some filters, picking the background environment, laying in the lanes, and then identifying where the left and right lane is, and even where the center of the vehicle is relative to the lane, so that you can detect whether or not you're going to be leaving the environment or not. Very simple example. Obviously, if you're doing this commercially on a product, you would develop it much further than that, but the capability is definitely there. So that was an example of running 2 of the 3 environments. First in the original view, where you're using the studio to sort of create the environment, and you can pre-run a simulation just to make sure that it's behaving the way you want it to. Then running in an offline mode where there is interaction through programmatically with some of the sensors where you could develop something. And then, of course, we also support running on our simulators. So when we run driver in the loop, basically in the WorldSim scenario, you identify one of the vehicles as your ego vehicle, and then on the simulator, the controls of that vehicle, instead of being run through the AI engine, are presented from the occupant of the simulator itself. So all of the steering inputs, throttle, determining what gear you're in, if there's gear shifting, is coming from that. And then, of course, WorldSim is running and presenting back on the simulator the graphics environment. One of the things that's very nice about this is you can define the scenario once, you can do it on your desktop, and then you can implement it on multiple simulators. And we run through this on the simulators. It's an integrated process, and we've got optimized capability on the graphics. You know, on a typical large dynamic simulator, you may be running 5 different projectors. Each one's running its own WorldSim instance. If you've got reverse cameras, those could also have an instance. You can also potentially have custom WorldSim processes running different sensors. And all of those get run on the simulator with a fixed clock that's shared at 120 hertz. So it's a very robust environment. Okay, running through projectors is great, but we also support a VR and AR environment. So with WorldSim and on our simulators, we can identify regions, whether you're using a green screen or you do it through location control, where you define areas that WorldSim is going to present the visuals from, with other areas where you're presented a direct visual view. So if you want to be able to see the steering wheel, see your hands, be able to interact, but simultaneously where the windows on a cockpit would be, the WorldSim projection is coming through, that can be presented. And we have used a number of different kinds of headsets. The Vario XR3 is probably the gold standard that we recommend, but there are other ones. Basically, any object that supports OpenXR, any headset we would support. Of course, the resolution and fidelity will then be sort of headset specific. So here's an example video shown from inside a vehicle with the headset on, and we're showing a couple of new features. There's a heads-up display. There's a screen that we can project objects onto for that. We're pretty proud of the way the mirroring works, because the view that's showing up in those mirrors is directly related to the position of the headset. So as you move your head around, the view changes. In fact, you can even, just like in a real vehicle, you can change the orientation of the mirror. And then the other thing that was kind of shown in here is there's direct pass-through display of right there's an example of a display that you have programmatic control of separately. You can physically do it on the simulator, and then it gets presented into the headset display, so that those dashboards are dynamic as you're driving. You know, if you're monitoring speed or what gear you're in, all of that information is dynamically updated right in there, just like it is on the physical device. So that's pretty much the content that we plan on presenting. Appreciate you joining the webinar. We do have an offering for people that have come today to this WorldSim demo for a 30-day right after the training free of charge demo on site, and a 15% discount. This is a scenario and an environment that is emerging, but it's very robust right now. We're putting a lot of investment in it, and obviously, hopefully, you could see that just graphics capability has progressed immensely over the last, let's say, 5-10 years, and it is going to continue to happen. And we would like to think that we're close to the bleeding edge of leveraging that content when it's available. And last, I would just say, when making a decision on using one tool or another, WorldSim does have some competitors, but I strongly recommend that you assess both the product, but also the company behind the product. I think you'll find that VI-grade is an excellent partner in this space. And one of our strengths I would like to point out is, we have a set of tools that we provide, but we recognize that customers have many tool sets and they need to integrate all of them. And we're very agnostic on methodology and willing to work with you on the environment that you're working in and how to get WorldSim integrated in it. So with that, I recommend taking a peek at it. You can leverage this demo license now and contact somebody from VI-grade. It could be myself or someone else if you would like to understand more, and let's get started.